And then you can move all the way to how do you remove tanks and get into tankless kind of operations, which we've actually currently trying out in the Permian, in the Delaware Basin on a couple of areas, where you're actually moving the fluid straight into, the LAC units and into the kind of gathering system without going into settling tanks. So that's kind of how you can kind of move through the technology and all existing technology, and that's a lot of other kind of research activities out there to try and find, electric actuators that is reliable and low cost as another kind of means of reducing overall kind of emissions.
So Bernard, you have been doing getting up into the air.
Well, we've been, I guess starting on the ground, one of the things similar to what Ståle was talking about is we also have chemical injection pumps, for example, that are powered by gas that can emit product, and we've actually been converting them to solar-powered chemical injection pumps. So a simple photovoltaic cell lined up with a battery that powers the pump, and it works, and it's very cost-effective. It's very simple. But the real exciting part for us has been around, we start with this regulation that says let's visit the well site physically twice a year, and a lot of companies are experimenting with how do we actually make that more continuous. So we've got a drone in the air at the moment. Lots of people have drones in the air. What's special about this one? It's got 3 cameras. It's not that they're all 3 cameras the same. It's got a laser camera, it's got an infrared camera, and it's got a camera doing general layout. Through the BHP transaction, Dan, we'll take on about 1,500 wells. We believe that with this one drone, and of course this can be multiplied, we can visit and inspect 1,500 wells every 30 days. And by the way, when it detects a leak at any location, it instantaneously generates a work order in the cloud that goes to the maintenance management system, such that when the technician comes to work the following morning, they have a work order to go to the field to repair that exact piece of equipment. And the cost effectiveness of this is probably 90% of what a physical operator would cost, 90% less, 10% of what it would take to have an operator go to the field. But then you say, well, 30 days isn't enough, because Fred's work with the EDF, a report that they published last year, which says that, well, you're only measuring periodically, and there are upset conditions that happen that you're not capturing. And I think that's a very valid thing to challenge. So permanent observation is the key, and Fred will talk about the ultimate permanent observation, but what we're doing is we've just installed a permanent camera at our site in Kazan in Oman, which we're trying to get to where you can scale up. And a project that we're building in Calcasieu in Trinidad today will have 4 cameras on it that have a range of 100 meters, and that will be, it's not a large facility, that will be sufficient permanent camera coverage that can be permanent, that will detect leaks on a 24/7 basis.